Okay, so welcome to the week 5, and in this week we're going to cover the machining processes in both the lecture and in the lab. And also this week we're going to start with the mini project, which is the manufacturing of the wind turbine, and you will present it. I think that the task is already available right now at on the canvas, and also we're going to play some slides during the lab session. The student will be advised to create the groups, and they can register these groups on the canvas. This group is going to be available by tonight. Now let's go back to the main topic, which is going to be about the machining processes and the investigation of the different parts that are made by different manufacturing processes. The machining processes in general is going to be following up the bulk deformation processes and solidification processes. So let's go with one of the example we had earlier, which was this cassette part. Remember that this part was casted by the die casting process when we had multiple sections for the mold closed, and we injected the molten metal inside, the part solidified. In general, we made the internal details by using the core. And the core gave me the internal details, but it's not going to give me the required surface finishing or some details like the thread we have inside. So after we did the casting process, we need to follow with another process, which is going to be the machining processes to get the part ready to work. So we have a net shape process, which what we had with this part, that we can use it directly, and we always going to reach the near net shape process that required an extra machining processes to get the good details and the specific details for the part. So here what we can see is that we have flat shiny surface. We had flat shiny surface as well with two holes, threaded holes, threaded, okay, of course threaded for the plug here. So many of these details has been made by two operations. The first was the face milling. We just put the part under the milling machine and we start to remove a layer from the top. So the machining process is the process of removing some of the materials by the means of using the cutting tools. These cutting tools can be a single tip cutting tool and can be a multiple tips cutting tools. At the end, we're going to reach the aim of removing the material in the form of small chips. So if I would like to reach this good surface finishing from a cassette part, definitely I'm going to use the face milling, and it's going to be done in multiple steps. The first step is going to be the rough cutting, which is removing a rate of the materials at higher level to reach near to the required height. And then again to do the finish cutting, which usually going to be 1 or up to 2 steps to remove the materials in very thin layer in order to reach the desired surface roughness. So we talked about the milling operation. We talked about the face milling operation. In the milling operation, the part will be set on the milling table. Table will be moved to the X, the Y. The cutting tool will be moved along the Z axis. Usually the face milling cutting tool is going to have a multiple cutting tools. So we are going to call it as a multiple tips or multiple teeth cutting tool. Each one of these teeth is going to remove a certain amount of the material, then leave, then come back to do the cut again. And also we talked about rough cutting, which is going to be done at higher RPM value, lower RPM value, but higher feed rate and high depth of cut. The finish cutting, we're going to increase the RPM, we're going to slower the feed rate, and the depth of the cut is going to be shallow. The other operation we can have here, usually this part doesn't look like a part that can be rotated around the center, as a symmetrical one. So no turning operation is going to be used here. But because we have a holes with the tips, that means we use another machining operation which is called the drilling, followed by the other operation which is called the tapping. The drilling is the operation that makes the hole. The tapping is the process to make the thread. If the part is going to be symmetrical, like if I'm going to have a look to this shaft, at any section of it, the part is going to be symmetrical. The two halves will look the same. The four quarters will look the same. The part can rotate. To cut that, we can do it on the milling machine. I cannot say we cannot do it on the milling machine, but this one usually going to be done on the turning machine. In the turning machine, the part is going to be held on one side, and we start to remove the materials layer by layer. I'm going to use a single tip cutting tool, start to remove the materials, going from the beginning till the end. Okay, then we leave the part, coming back and start to do the job again. Layers by layers by layers. Usually to go from this diameter to that diameter, I need to do a rough cutting, which is removing the material at higher rate. We don't consider what will be the surface roughness to be achieved. Then we're going to leave some like 0.25 millimeters or 0.5 millimeters, and we're going to use this layer just to achieve the better surface finishing, and this can be done simply by do the finish cut. So once again, for the milling operation, turning operation, single tip cutting tool, start to cut from the front. This part was actually a cylinder. Start to remove one layer, leave, come back from the beginning, deeper layer, and deeper layer. We do it as a sections, then the finish cut will be starting from the point in the middle, go all the way, removing only 0.5 millimeters, then leave the part. 1 or 2 maximum passes to achieve that. So that's the turning, that's the milling operation. What you can see here that my movement for my cutting tool was, I just simply insert the cutting tool to a certain depth, then moving all the way till the end, leaving and come back. So my movement, as you can see here, is going to be along 2 axes. The first axis is going to be the x-axis, the other axis is going to be the z-axis. The part is rotating. The rotation axis is going to be the z-axis. The cutting tool movement is going to be along the z-axis when you do the feed rate. Depth of the cut is going to be on the perpendicular axis, which is going to be the x-axis. In the case of the milling operation, that will be the z-axis. That's the x-axis, which is the longest side of the table. The shortest side of the table is going to be the y-axis. So you can see that the turning operation is going to be 2-axis operation, and the milling operation is the 3-axis operation. If I'm going to go back to a drilling operation, you can see that the cutting tool is only going to move in one direction and also rotating around the same axis. And that means that the drilling operation is going to be a single axis operation. So most of the other operation we can do with the machining is going to, for example, on how to cut the gear. This can be done by multiple operations, and that's explained actually in the lecture. But in general, we can have a cutting tool which has the same details of the gear details. It's only going to go and do the cut. Usually, we're going to have the part to be divided to an equal number of divisions, which are the number of the grooves we have in the gear, or the number of the teeth of the gears. When I say division, it's not going to be angle, it's divisions. Number of the teeth is going to be dividing the circle into an equal divisions. So we do that by holding the part on what we call it the indexing tool. Indexing tool, if I'm going to set the number of the divisions to be 22, then it's going to be moving to a different 22 positions. And each time the cutting tool will be passed through and do the cut. Another way to do that is going to be the hopping operation, where the part is going to be moving and the contractor will start to remove the material. We have different hopping tool. The other one is going to be the hopping tool that have the teeth, multiple teeth rotating, and the part is passing it through, rotating against each other by 90 degrees, and then we're going to have the details here. And I can send you a video later on how this spline is also can be cut by both the milling operation, or it can be done by the hooping operation. We have multiple operations, like for example, if I would like to have a hole to be expanded, okay, so I can drill it, then I can simply increase the dimension of it. And that's the process we call the boring, because the part is going to be bored. This will be something opposite to what we have in the case of the turning, because in the turning we reduce the diameter from the outside. This one is increased diameter from the inside. Something similar to the drilling, but the drilling actually is creating the hole. The boring is increased diameter of that hole. Okay, so I will stop at this stage, and everything else is going to be talked about in the lab, and also you're going to be able to inspect the parts in the lab, and then you will mention how each part or how each surface was made. Okay, thank you very much.